Now that we have studied the relative velocity, let's do a very interesting question from relative velocity. Okay, on the simpler terms, suppose there is this train A which is moving at 60 km per hour, and on the same track we have another train B which is moving towards train A with the same speed 60 km per hour. Okay, now both are on the same track, that means obviously both the trains are going to collide in a while. So I want you guys to tell me, if their distance is 120 kilometers, in how much time the trains are going to collide? This is the question. It's a very basic question. See, if you have to calculate the time in which train A is going to hit train B when train B is at rest. Right now the train B is moving with 60. I'm telling you, if B is at rest, how would you calculate? You will simply take the distance and the speed of train A, right? So similarly, on the similar grounds, what you have to do, find the relative velocity of A with respect to the B. That means B is at rest now. When B is at rest, so how do we do that? The application of relative velocity as per the superposition of negative velocity on both the objects, which I have told you in the last class, that I apply minus 60, that means 60 is in this direction, so minus 60 is in this direction, 60 and 60 on both the bodies. So the net velocity of A remains what? It becomes 120. It was already moving with 60, and with the application of another 60 it is moving with 120 km per hour, and train B is now at 0, right? So distance when train B is at 0, that means train B is at rest. So the distance train A has to cover to get in collision with train B is 120 km. Distance is 120. So what would be the time frame? Time would be what? What is the formula of time? Distance over velocity or speed. I am writing distance from S. Speed is not S. Mind this thing. Speed is not S. Distance or displacement is represented by S. So how did this formula come? We already know that velocity is speed over time. So distance over time. So velocity, distance, or you need to find what? The time. Time is displacement or distance over velocity. So this is 120 over 120 gives you 1 hour, right? Okay, one more thing, very basic thing for you guys to understand, that if you are doubtful in your answer anywhere, no matter which chapter you are doing, if you have the slightest hint of the doubt, do one thing, try to calculate the SI unit of the answer which you have done. For example, here on the numerator side the unit was kilometer because it was the distance. Okay, stop getting confused. I am writing it as D. Done? So much easier for you now. On the denominator side, what do I have? I have kilometer per hour. This R, this is A upon B by C format. So this C will go up. This is basically A into C by B. So here this kilometer gets cancelled out and you are left with R only. So we were calculating time and our unit is in hours. So this will give you an idea whether your answer which you deducted is right or wrong in terms of units, right? Now, let's complicate the same question on the same thing, on the same data which was given for these two trains. We have a new introduction of a bird. There is this bird here. This I'll write down here somewhere. This distance is 120 kilometers, this whole distance. Okay, and there is this bird. This is my bird. So I have already used the alphabet B, so I would write it C for Chidiya. So there is this bird C which is moving or which is flying towards train B at the speed of 120 km per hour. Now what this interesting bird is doing right now, this bird is flying towards train B, it is touching the train B and coming back towards A, it is touching train A and then it is flying towards B, and this way the bird is doing like this. So if you just draw the trajectory of the bird, when the bird started from here, the train B was here, but in the time while she came from here, train B must have reached somewhere here, right? we're just taking the approximate idea of what this bird C is doing. It touches train B, it goes back towards A, but in that time train A would have covered this much plus some more distance here. Train A is here, and then it flies towards B. Till that time B must have came more closer towards A, and this way the distance is diminishing, right? So we need to find out how many trips did the bird make before the collision happened. Number one. Number two, we have to find the total distance covered by this bird C. First thing, we need to find total number of trips which the bird make before the trains collided. Number two, we need to find out total distance of the bird which it covered before the collision. Okay, we'll start. How should we start now? No idea. Let's see. I always suggest my students to always think on the paper. Thinking on the paper means start scribbling down, start writing the data, analyze it, and start from any formula you know. You will actually reach to some sort of conclusion that okay, this formula was not to be taken. That's it. This is the maximum effort you can do, right? So start from anywhere. We will calculate first trip, and it's very simple. How do we calculate the first trip? Actually, I have to calculate the number of trips the bird makes. So for that, what I'm doing, during the first trip, how much time did the bird take? This is what I'm calculating. This is my approach. So during the first trip, the bird was traveling from C to B. So I'm finding the velocity of C with respect to B. That means which is at rest now? The train B is, I'm putting the train B is at rest. So the velocity of C with respect to B is 120 plus 60, right? I don't need these now. So 120 plus 60. So this is 180 km per hour, and the train B is at rest according to this. So the distance it has to cover is 120 kilometers. So what would be the time taken? Time taken would be 120 over 180 hours. That is what? 2.3 hours, right? So this is something which we know for very sure that first trip is going to happen, and the first thing will conclude in 2.3 hours. Number two, before I go towards second trip, should we calculate how long or what distance did these trains covered before this bird C reaches train B? The time taken by bird is 2/3 hours. That means this is the time in which both the trains have already traveled some distance. So distance is what? Distance is equal to speed into time. Speed is of each train is 60, and the time is 2/3 hours. That will give you 20 into 2, that is 40 kilometers. So 40 kilometers is the time both the trains have already covered, and this train, that means this train has covered, this train has covered 40 kilometers. This train has covered 40 kilometers. So what is the left? Total was 120, that means 40 is the remaining. Right? So we are done with the first trip. Let's calculate the second trip. In second trip, the bird is what? Where is the bird and where are the new positions of train? Train B has reached here, train A has reached here, and bird B is here, right? Bird C is on the top of train B. Now the bird C flies back towards train A. This time the bird will be covering 40 kilometers with the speed of, again if I put velocity of what? Bird C with respect to train A, the velocity will come out to be what? It is going back again with 120, A is coming towards with speed of 60. So 120 plus 60 gives you 180 km per hour again. Velocity is this, distance to be covered is 40 kilometers. That means time would be 40 over 180. This will give you 2 over 9 hours. This is clear? So second trip is the second trip is also possible, and number two, we can also find out the distance what the trains covered in this time. So distance covered by both the trains during this much time was 60 speed of train into the time, 2 upon 9. That is, this is 20, this is 3, this gives me 40 over 3 kilometers. 40 over 3 kilometer means I am dividing 40 into 3 parts. So whatever distance which was left in between, which was 40 kilometer, this distance has to be divided into 3 parts. One train has covered 40 upon 3, the other train has covered 40 upon 3, and the remaining distance would obviously be 40 upon 3, right? So new positions of train are here. This is train B, this is train A, and the bird is now here flying towards train B. Now, so we need to calculate the third trip as well, and we are going to find the trips until and unless the distance between them is 0, right? This is what we started from the idea. So I am calculating the third trip now. For the third trip, I won't write it in detail, I am doing the shortcut now. Velocity of bird with respect to train B, because the bird is traveling back towards train B, will be 180 again, and the distance to be covered is 40 upon 3. So time taken would be 40 over 3 divided by 180. This will give you 40 over 3 into 180, right? This is 2, this is 9. So you are left with 2 upon 27 hours. Now, during the first trip, the time taken was 2 upon 3 hours. In the second trip, the time was 2 upon 9 hours, and in the third trip, the time is 2 upon 27 hours. Is there any symmetry here? So the next trip would be 2 over 81 hours. What the denominator is getting multiplied by 3, and the next trip would be 2 upon 243 hours, and so on. So the idea is that no matter how many whiteboards do we fill right now, we will never get to the conclusion, because the time right now is in hours. It will ultimately reach into minutes. From minutes it will go into seconds and millisecond, micro, nanoseconds, and you will not find the final answer. So the answer, the real answer of this question would be infinite many trips, right? Yes, this is infinite many trips. But we can find the total distance covered by a bird in 2 different ways, okay? I hope you have already noted it down. So we'll find the total time. The simplest way is, before I started this numerical, I asked you guys that what would be the time taken by both the trains to get into collision, and the answer was what? 1 hour, because the relative velocity of bird with respect to train was, no, not bird, with relative velocity of one train with respect to another was 120, distance covered was also 120, so time was 1 hour. So ultimately the bird has to fly for 1 hour, and the speed of bird is 120. So you can simply multiply 120 into 1 hour, the velocity into time, and you will get the distance. That is, the total distance which bird will cover would be 120 kilometer. How did we do that? Total time in which the trains are going to collide is 1 hour. Total, the speed of bird is 120, so it is going to fly with this speed for 1 complete hour, and that is going to give you the total distance covered by the bird. But there is another method to find it out, just to prove that whatever we just said was right. So what we are going to do is, see, what is total distance? Distance is speed into time, right? Speed is 120 into time, the total time taken by bird. What was the total time we just calculated? 120 into the time is, first of all, it was 2 by 3 hours, plus second case it was 2 upon 9 hours, plus 2 upon 81 hours, then 2 upon 243 hours, and so on. We never reached the answer. So this is basically a geometric progression. If I take 2 upon 3 common out, I will be left with 1 plus 1 upon 3 plus 1 upon 9 plus 1 upon 27, and so on up to infinite terms. This is the basic geometrical progression for which you already have the formula. What is the sum of GP for infinite terms? A over what? 1 minus R. A is the first term, 1 minus R is the common ratio. This is the sum of GP up to infinite terms. So I will be left with A is what? First term 1 over 1 minus the common ratio is 1 upon 3. So 3 multiplied here, 3 minus 1 is 2, and 3 goes up. So 3 upon 2, right? So this 3 upon 2 is basically the whole thing. So you are left with 120 into 2 upon 3 into 3 upon 2. This goes, and you are left with 120 only. So both ways you will get the same answer, even if you find the geometrical progression method or the simpler method that the total speed of bird was 120, it has to fly for only 1 hour, so ultimately it has to cover the distance of 120 km only, right? So this concludes our relative velocity.